एनर्जी स्टोरेज टॉपिक को हम 3 पार्ट्स में कवर करेंगे। इट्स इंट्रोडक्शन, टेक्नोलॉजीज एंड बेनिफिट्स। एनर्जी के विभिन्न रूपों को स्टोर करने के लिए यूज में आने वाली प्रोसेसेस एंड टेक्नोलॉजीज के ग्रुप को हम एनर्जी स्टोरेज सिस्टम कहते हैं और इसके द्वारा हम लो कॉस्ट जनरेटिंग सोर्स से इलेक्ट्रिसिटी प्रोड्यूस करते हैं और उसका उपयोग जो है हम पीक्स डिमांड के समय में करते हैं। एनर्जी स्टोरेज का यूज माइनर फ्लक्चुएशन, जब एनर्जी के आउटपुट में मिलता है उसे उसमें स्मूथ करने के लिए किया जाता है और इसे स्मॉल एंड लार्ज इलेक्ट्रिसिटी जनरेशन सोर्सेज में यूज किया जाता है। सो वी कैन से energy storage systems are the set of methods and technology used to store various forms of energy. Energy storage enables a lower cost generating source to produce electricity at a different point in time to be stored and then used to meet times of peak demand. This flexibility has the potential to transform how we produce and consume electricity. Energy storage is also commonly used to smooth out the minor fluctuations in energy output for small and large electricity generation sources. Storage system also provides increased reliability and strengthens system resilience at large and small substation levels. There are many different electrical energy storage technologies. Say for example, in electrical, capacitor, supracapacitor or SMES means superconducting magnetic energy storage. In mechanical technology systems, PHS means pumped hydro storage. CAES means compressed air energy storage. FES means flywheel energy storage. अब हम इलेक्ट्रोकेमिकल टेक्नोलॉजी देख सकते हैं या इलेक्ट्रोकेमिकल मेथड्स देख सकते हैं कि कौन कौन से उसमें हमारे एनर्जी स्टोरेज डिवाइसेस हैं। So, secondary battery, lead acid battery, ultra battery, sodium sulfide battery, lithium ion battery, nickel cadmium battery, metal air battery. Flow battery की बात करते हैं हम तो redox flow VRB means vanadium redox battery. Next is hybrid flow जिंक ब्रोमाइड बैटरी। थर्मोकेमिकल टेक्नोलॉजी में हम सोलर फ्यूल का यूज करते हैं एंड इन केमिकल टेक्नोलॉजी हाइड्रोजन फ्यूल सेल का यूज करते हैं एंड इन थर्मल टेक्नोलॉजी CES का फुल फॉर्म है क्रायोजेनिक एनर्जी स्टोरेज। ALTES मींस एक्वाफेरस लो टेम्परेचर थर्मल एनर्जी स्टोरेज। TES means high temperature thermal energy storage. There are several benefits of energy storage systems. First is security. A more efficient grid that is more resistant to disruptions. Second is environmental security. Decreased carbon dioxide emissions from a greater use of clean electricity. Next benefit is economy. Increase in the economic value of wind and solar power and strengthen competitiveness in the clean energy race. Next benefit is jobs. New income sources for rural landowners and tax revenues for wind and solar development areas. More jobs in supporting sectors like manufacturing, engineering, construction, transportation and finance. Next topic is fossil fuel. We have to study coal, oil bearing shell and sands, and last is coal gasification. So first of all, what is fossil fuel? Fossil fuels means जीवाश्म ईंधन प्राचीन पौधों और जानवरों के अवशेषों से बना है जो पृथ्वी के अंदर लाखों वर्षों से गहराई में है। बहुत लंबे समय से हीट और प्रेशर ने इन अवशेषों को फॉसिल फ्यूल्स में बदल दिया है, जिसे हम कोल, ऑयल एंड नेचुरल गैस कहते हैं। So we can say fossil fuels are made from the remains of ancient plants and animals buried deep inside the earth for millions of years. Over a long time, heat and pressure has turned these remains into the fossil fuels that we call coal, oil and natural gas. Fossil fuels are widely used because there is a good supply and they are fairly cheap to mine and to drill for. However, fossil fuels are non-renewable. Now the first fossil fuel is coal. और जो कोल को पढ़ेंगे हम, उसके हेडिंग्स रहेंगे इंट्रोडक्शन, फॉर्मेशन ऑफ कोल, वैरायटीज ऑफ कोल, एडवांटेजेस, लिमिटेशंस, यूजेस एंड सिनेरियो। So introduction of coal. कोल एनर्जी का एक नॉन रिन्यूएबल रिसोर्स है। मतलब ये कि कोल पृथ्वी से अंततः समाप्त हो जाएगा। कोयले को नेचुरल फॉर्म में प्रिपेयर होने में करोड़ों वर्ष लगते हैं, इसलिए हम इसे बहुत जल्दी वास्तविक रूप में नहीं बना सकते हैं। कोल में एनर्जी की बहुत बड़ी क्वांटिटी होती है जो डेड ऑर्गेनिक मैटर यानी डेड प्लांट्स से आती है, जो इस धरती पर करोड़ों वर्षों पहले दब गए थे। Once these plants are died, they are formed in layers in the marsh floor in which they grew up. So हम कह सकते हैं coal is a non-renewable resource which is being used by humans as their primary source of energy for industrial needs and generation of electricity. It forms a major part, about 37% of producing electricity. Coal is a rock formed from the decomposition of plant life, though coal is made up of carbon and other elements like hydrogen, oxygen, nitrogen, sulfur to form some parts. Capacity of coal to give energy depends upon the percentage of carbon content. So, older the coal means more is its carbon content. Coal's high energy density and extensive reserves found in nature make it useful as a fuel for electricity generation in coal-fired power plants and in some places. How coal is formed? Over time, plant matter पर जब वाटर और डर्ट इकट्ठा होने लगता है तो फॉसिल फ्यूल का निर्माण होना शुरू हो जाता है। करोड़ों वर्षों से तीव्र गर्मी और दबाव में केमिकल एंड फिजिकल चेंजेस की वजह से प्लांट मैटर कोल के रूप में चेंज हो जाता है। This is the description of coal. formation. Coal is found deep inside the earth in the form of coal beds. Coal was formed by anaerobic thermal degradation of the cellulosic material of big plants, trees, which got buried inside the earth millions years ago. Conversion of wood into coal are slow process and may take thousands of years to take place. The slow conversion of wood into the coal under the influence of high temperature, high pressure and the absence of the air. It is termed as carbonization. Wood under the effect of high temperature and pressure and in the absence of air gets converted into coal through a number of steps. Each step leading to increased carbon content.
Let's see how coal is formed. Coal is formed due to the process of carbonization. Let's see what is carbonization. Million years ago, the earth had dense forests in lower-lying wetland areas called swamp. Over the time or due to natural processes like flood, these trees died and got buried under the bottom of the lake or ocean. Now, this is the organic matter. As these trees decompose, they become peat. As more soil called sediment deposited over them, they were compressed and become soft coal called lignite. The more sediments collect over the top with time increase heat and pressure. Under high pressure and high temperature, the lignite got slowly converted to coal. As coal contains mainly carbon, the slow process of conversion of dead vegetation into coal is called carbonization. Since it was formed from the remains of vegetation, coal is also called a fossil fuel. Coal is taken out by digging deep inside the earth.
Now the stages of coal formation. In the process of transformation or coalification, peat is altered to lignite, lignite is altered to bituminous, and bituminous is altered to anthracite. So formation of coal में first form of coal is peat, second is lignite, third is bituminous, and fourth is anthracite. Now coal varieties. Peat is the first stage of transformation, contains more impurities like sufficient volatile matter and lots of moisture. It burns like wood and emits more smoke and leaves a lot of ash. Lignite. Second form of coal is lignite. Sometimes it is called brown coal. It is the youngest of coal types and has lowest energy content, containing between 25 and 35% carbon. Lignite usually has not been subjected to extreme temperature and pressures. It is commonly a high moisture content and is typically burned in power plants and electric production. Next is bituminous. This coal contains anywhere from 45 to 86% carbon, giving it an even high heating. Next is anthracite coal. Anthracite contains 86 to 97% carbon. It is highly desirable fuel because of its high energy content and low sulfur content. Supplies are limited in most areas. Here we can see the heat content and carbon content of the different varieties of coal. From peat to anthracite, increasing heat content and carbon content. From anthracite to peat, increasing moisture content. So good quality of coal is anthracite. Advantages and disadvantages of coal. Advantages. Coal energy is an affordable energy source because of the coal's stable price compared to other fuel sources. Coal is easy to burn. Coal produces high energy upon combustion. Coal energy is inexpensive. Coal is abundant. Coal energy is a reliable energy source. Disadvantages of coal. Coal energy produces large amount of carbon dioxide, which leads to global warming and climate change. The burning of coal is not environmental friendly because it produces harmful byproducts and gas emissions like oxides of sulfur, carbon and nitrogen that causes pollution to environment including acid rain. Coal energy is non-renewable energy source. Coal is fast depleting because we consume too much of it. Coal mining ruins the environment and puts the lives of people, especially the coal miners, in danger. Now, uses of coal. Here is a list of all the major uses of coal. First is generating electricity. Coal is generally used in thermal power station, which further helps to produce electricity. Powdered coal is burnt at high temperature, which further turns water into steam. This steam is used to turn turbines at high speed in a strong magnetic field. After this, electricity is finally generated. Second use of coal is production of steel. In the steel industry, coal is used indirectly to make steel. What happens here is that coal is baked in furnaces to form coal coke. Once this is formed, manufacturers used coal coke to smelt iron ore into iron and make steel. Meanwhile, ammonia gas is usually recovered from coke ovens, and this is used to manufacture nitric acid, ammonium salts and fertilizers. In industries, many industries use coal to manufacture certain products. Some of the popular industries which make use of coal are cement industry, paper and aluminum industry, chemical and pharma industry, etc. Coal provides numerous raw materials like benzol, coal tar, sulfates of ammonia to chemical industries. Coal is mostly used as a source of energy in most of the industries. Next use of coal is gasification and liquefaction. Coal can be turned into synthetic gas, which is a mixture of carbon monoxide and hydrogen. These gases are an intermediate product that can be further converted into different products like urea, methanol, pure hydrogen and many more. Coal can also be turned into liquid known as synthetic fuels. Domestic use of coal. In cold regions and in developing or underdeveloped countries, coal is still used as a fuel for cooking and a source of heat. Now, Indian scenario of coal. India's proven coal reserves as of December 2018 is 101.3 billion tons and accounted for more than 9% of the world's total. इंडिया में मेजर हार्ड कोल डिपॉजिट्स जो हैं वो झारखंड, छत्तीसगढ़, उड़ीसा एंड वेस्ट बंगाल में मिलते हैं, जो कंट्री के टोटल कोल रिजर्व्स का 70% शेयर है. आंध्र प्रदेश, मध्य प्रदेश, महाराष्ट्र आर द अदर सिग्निफिकेंट कोल प्रोड्यूसिंग स्टेट्स इन इंडिया. India is the second biggest coal producer and consumer after China. More than 70% of India's electricity generation is based on coal. Now, world coal scenario. More than 70 to 80% of the world's total proved coal reserves are located in just 5 countries. The US tops the list, holding more than 1/5 of the total proven coal reserves, while China ranks third, is the best producer and consumer of coal. Mining technology profiles the 5 countries with the biggest coal reserves based on total proved reserves. United States of America. USA holds the world's biggest coal reserves. The nation's proved coal reserves as of December 2018 stood at 250.2 billion tons, accounting for approximately 24% of the world's proven coal reserves. Then Russia. The Russian Federation's proven coal reserves as of December 2018 accounted for 15.2% of the world's total. Third is Australia. Australia's proven coal reserves of 147.4 billion tons account for approximately 14% of the total proven coal reserves in the world. Then China. China's proven coal reserves constitute 13% of the world's total. More than 70% of China's proved recoverable coal reserves are located in north and northwest part of the country. Next, India. India's proven coal reserves accounted for more than 9% of the world's total. The major hard coal deposits of the country are located in eastern states of Jharkhand, Chhattisgarh, Odisha and West Bengal, which accounts for more than 70% of the country's coal reserves. So, अपना next topic है oil, natural oil. It is a relatively abundant, but it is a non-renewable resource. और डे बाय डे इसकी सप्लाई कम होती जा रही है. इसकी हाई एनर्जी डेंसिटी के कारण इसके बहुत से एडवांटेजेस हैं, बट मेजर एडवांटेजेस टू प्रोड्यूस प्रोडक्ट्स लाइक ट्रांसपोर्ट फ्यूल्स. अप्रोक्सीमेटली 71% ऑयल की कंजम्पशन ट्रांसपोर्ट सिस्टम को सक्षम करने के लिए उपयोग की जाती है. The production and use of oil also come with many social and environmental challenges. Producing oil causes land disturbances और environment के प्रति भी यह अति संवेदनशील होता है. हालांकि यह उपयोग की जाने वाली टेक्निकल प्रोसेसेस के आधार पर बहुत भिन्न होता है. The world's oil-powered transportation system contributes significantly to global greenhouse gas emissions and climate change also. Additionally, control and trade of oil resources different countries के बीच और स्थानीय स्तर पर कई समुदायों के बीच में राजनीतिक तनाव भी पैदा करते हैं. क्रूड ऑयल, नेचुरल ऑयल, कच्चा तेल को हम आगे डिस्कस करने वाले हैं. उसमें हम डिस्कस करेंगे इसका इंट्रोडक्शन, fractional distillation, advantages, disadvantages, uses, and scenario. Now the introduction. Oil is a naturally occurring unrefined petroleum product composed of hydrocarbon deposits and other organic materials. A type of fossil fuel, crude oil, can be refined to produce usable products like gasoline, diesel, and various other forms of petrochemicals. It is a non-renewable energy resource, which means that it cannot be replaced naturally at the rate we consume it, and is therefore it is a limited source. Through exploratory activities like seismic, well sampling, and subsurface mapping, geoscientists locate sites for oil drilling. The substances of crude oil can be separated using fractional distillation because they have different boiling points. क्रूड ऑयल में डिफरेंट सब्सटेंसेस होते हैं जिनको सेपरेट करने के लिए हम फ्रैक्शनल डिस्टिलेशन प्रोसेस का यूज करते हैं, और ये फ्रैक्शनल डिस्टिलेशन प्रोसेस सब्सटेंसेस के डिफरेंट बॉइलिंग पॉइंट्स पर आधारित होती है. The crude oil is evaporated and its vapors allowed to condense at different temperatures in fractionating column. Each fraction contains hydrocarbons with a similar number of carbon atoms. चूंकि different substances का different boiling points होता है, तो ये different temperature पर condense होते हैं, मीन्स वेपर्स में कन्वर्ट करके हम इन्हें कंडेंस कर लेते हैं. द मेन फ्रैक्शंस इंक्लूड रिफाइनरी गैसेस, gasoline, naphtha, kerosene, diesel, heavy fuel oil and bitumen. जो मेजर फ्रैक्शंस होते हैं, जो डिफरेंट सब्सटेंसेस हमारे क्रूड ऑयल में प्रेजेंट होते हैं, उनमें रिफाइनरी गैसेस, गैसोलीन, नेप्था, केरोसिन, डीजल, हैवी फ्यूल ऑयल एंड बिटुमिन शामिल हैं.
In today's video, we're going to take a look at crude oil and see how we can separate it into its different components using fractional distillation. Crude oil is a fossil fuel that we get from deep under the ground and is basically a mixture of lots of different compounds. Nearly all of these compounds, though, are hydrocarbons, which contain only hydrogen and carbon. And the most common type of hydrocarbons are alkanes, which we covered in the last couple of videos. Now, crude oil is formed naturally from the remains of dead plants and animals, particularly plankton, that died millions of years ago and were buried in the mud. Then, in the millions of years between then and now, the high pressures and temperatures under the ground turned this organic biomass into crude oil. As it formed, this crude oil soaked into the rocks and was stored for millions of years. But we can get it back out by drilling into the rock and sucking it up to the surface. As crude oil takes so long to form, it's effectively a finite resource. And if we continue to extract and use it at the rate that we are now, then one day we'll run out of it completely. This is why we refer to fossil fuels like coal, oil and gas as non-renewable fuels. Once we've extracted the crude oil from the ground, we need some way to separate out all of the different hydrocarbons in the mixture, because they each have different properties, and so we'll use them for different things. To do this separating, we use a process called fractional distillation, which involves heating the crude oil up and separating out different compounds by making use of the fact that the different compounds all have different boiling points. The first step is to feed the oil into a chamber and heat it until most of it has turned into a gas. We then pass this gaseous mixture into a fractionating column, which is really hot at the bottom, but gets cooler towards the top. The idea is that these hot gases will then start to rise up the column. But importantly, as soon as they reach a region that has a lower temperature than their boiling point, they'll condense into a liquid. The hydrocarbons with the longest chains, so the most carbons, have the highest boiling points, and so they'll quickly condense back into a liquid and drain out of the column early on, because it's not hot enough to keep them in their gaseous states. These are things like bitumen, which we use to surface our roads, and heavy fuel oil, which can be separated further and used for things like heating oil, fuel oil, or lubricating oil. The shorter chain hydrocarbons, though, have much lower boiling points, so they'll stay as a gas for much longer as they rise up the column until they finally reach a cool enough temperature that they condense into a liquid. This gives us fuels like diesel and petrol, which we use in cars and other road vehicles, and kerosene, which is used in jet engines. Some hydrocarbons, though, are so short and have such low boiling points that they stay as a gas the entire time. For example, LPG, which stands for liquefied petroleum gas, contains mainly propane and butane, which are both very short-chain alkanes. If we compare these different groups or fractions, the ones towards the top, which are the shorter chains, are the most flammable, and so they tend to make the best fuels. Meanwhile, the longer chain hydrocarbons, here at the bottom, are often poor fuels, so are instead either used for something else, or can be broken down into smaller hydrocarbons in a process called cracking, which we'll take a look at in the next video. The last thing to point out is that as well as all of these fairly direct uses that we mentioned here, petrochemicals, which is what we call all of these substances that we get from crude oil, can also be used as feedstock, which just means raw materials for the petrochemical industry, who use them to make things like solvents, lubricants, polymers, and detergents. Anyway, that's all for this video, so hope you found it useful. If you did, then please do give us a like and subscribe, and we'll see you next time. So hope you found it useful. If you did, then please do give us a like and subscribe, and we'll see you next time.
Now, advantages and disadvantages of oil. Advantages. Petroleum is extremely easy to extract. It is a high density fuel, can be transported over long distances, provides a stable energy resource, excellent solvent. Now, disadvantages. It is a non-renewable energy resource. It is not eco-friendly, means it produces carbon dioxide gas and pollute the air. This is a greenhouse gas that contributes towards climate change. Much of our oil has to be imported and it is becoming more and more expensive as reserves reduce and imports increase. Producing electricity from crude oil is expensive as compared to other fossil fuels like coal or gas. Now, uses. It is used as a medicine, make canoes, Dongi, waterproof treatment of frostbite, used in transport. Heavier products are used to make tar, asphalt, paraffin wax and lubricating oils. It provides the ingredients that are essential in products like soap, detergents and paints. It is used in burning lamps also.